Okay, thank you very much. Again, hello everybody. Now that we are expert on modeling, we are going into production, from modeling to production, the AFO, the ADM, and it's time for formality. And for the formality, we have guidelines and governance process. So we'll start with the guidelines for ontology term creation and reuse. These guidelines are ensuring that the creation of new terms with the Allotrope Foundation ontologies follows a consistent process. It identifies relationship of new term to existing terms, so terms are not overlap within the ontology, in conjunction with the ADM development to describe specific instances of data. Here is a list of the sources. This list is not limited. We can add additional sources, and this list means that we have license that permitting the use of those sources. We have a semantic style guide that specifies how terms of interest within a particular domain are harvested, stored, and enriched with the contextual metadata. It's based on the W3C RDF, and it aligns with the basic formal ontology. Within the guidelines, we find rules for taxonomies and ontologies, guidelines for namespaces, minting IRI, rules for auto-generating identifiers, the label syntax, and so on. To mint IRIs, we have the ID generator, and this is the screenshot of the unique ID generator. We can get IDs for different type of domains, such as the equipment, the function, the material. Each one, we can get the next single and unique ID. We publish the ontology on the Perl service. The Perl service is running on AWS, and the latest recommended ontology is the merge version March 2020. And this is a screenshot of our perl.allotrope.org. At the same time, we publish our ontology on the European Bioinformatics Institute, which is a repository for biomedical ontologies. It's well known as OLS. This is a tool to search within the ontologies, and you can use it to search the Allotrope ontologies for terms in the Allotrope ontologies as well. In parallel, we are publishing on the National Center for Biomedical Ontology. Also, it's an ontology search tool known as BioPortal. We have the ontology and model governance process, which is a streamlined process for the community project and the working group to guide the development of new ADMs and propose new AFO terms. It is actually a simplified model of the W3C classification level of maturity, going from working draft to candidate recommendation all the way to recommendation. The data model and the ontology development procedure following several phases. We start with model ideation and development. Next, we move into formalization of draft model and addition of taxonomy terms. Then we review the draft model. Then we have a public review phase, and we have periodic release of ADM and AFO. Specifically for the ADF software library, we have a software lifecycle support policy, which is published on our community website. And in a nutshell, it provides support lifecycle for a minimum period of 12 months for every single release. There are several phases: standard support phase, then we switch after a newer version to a maintenance support, which is almost identical, and before the end of life, a critical support phase. In general, we would like to encourage you to move to the latest and the greatest release. In order to streamline our software development lifecycle, we based it on GitLab. GitLab provides a unified platform that offers source repository, version control, automation of the continuous integration and continuous deployment, issue management, all under one roof. It actually optimizes our operation process and make it very transparent and efficient to the community. We're using the JFrog Artifactory as a repository for binary artifact, and we're using AWS for hosting our Perl server, Doc server, some of the optional GitLab job runners, and our community website. For the ADF Library Development, we're using the continuous integration and continuous deployment pipelines, which relies on GitLab, and including some of the following elements. We have the Maven build lifecycle for Java libraries, the NuGet packaging for C#, the GitLab source repository, and issue and CI/CD lifecycle automation. We can run, as said, additional jobs on AWS, and we have the JFrog Artifactory to store and distribute binary artifact in the build process. We have some new exciting products. The ADFC is an application for quick inspection of the ADF files and graph data. It has different approaches how to visualize graph, and it's under our open source community project. The ADF FC has some new features, but the main feature to mention is that the graph visualization usability, which is much more user-friendly because we are using the perf label to identify the resource. Some of the screenshots of the ADFC, we see here the tabular model, the violation of our serial number, we see here using the ADFC. So we see the import of the manifest file. And for example, our equipment serial number that we violated, we use two serial numbers, ABC and XYZ. And we see the tabular model, 1-to-1 triple measurement, conductivity, and temperature of 28.6 degrees Celsius. This is the graph, and if we want to search the graph, we can search for a keyword, measurement. We see the pref label, and we see the measurement identifier. This is the peak table with the chart of the chromatogram. We have the ADF Info, which include the ADF version, ADF checksum, data description, HDF structure, and this is just a few of the screenshots of the ADFC. In addition, we have the SHAckle Validator that I mentioned earlier. The SHAckle Validator, reminding you, evaluate conformance of ADF file data descriptor with a set of conditions in the SHAckle file. The way it is structured, it has a core validator, and it has a console option for command line, and a web user interface. And we will demonstrate the use of the SHAckle Validator. So I have here the web interface of the SHAckle Validator. I will plug in the shape. I will drop in the shape file, the conductivity shape file. And I will drop in the violating file or the conductivity with two serial number. Just to prove you that I'm violating, I have on the ADM instance two serial number, XYZ and ABC. I will now try to validate the file, and I got conforms false, and the severity is violation. Property may only have one value, but found two. Now let's try to validate the real ADM file. So I'll reset it. Again, I'll drop in the shapefile, and I'll bring the conductivity file. And just to preview this time, that my conductivity file have a single serial number. This time I drop the ABC and D, XYZ. Let's validate it. And I get conforms true. This concludes the demonstration, and I would like to pass the presentation to our product director, Matthew Fox.
Hi, everybody. Thanks. This is Matthew. If you weren't aware already, and you might not have joined the first introduction, we've now posted what is present on the screen right now on our website, so that folks can readily see what is available for all of the modeling. You can see the link right there. And then if you want to go to the next slide, Amnon, we've also updated the website with what's in progress. Most of this is driven through the modeling working group. Otherwise, it could be separate sub-teams that are working on this. We thought this was an appropriate way to give more insight into what's going on, and also to make it public so that any folks that are outside of the Allotrope community can still see what we're working on. If they have interest, this is something that could trigger that interest. And then I will pass it on to Ben, our senior engineer at Allotrope, who's going to be doing a bit of a background and demonstration with regards to the tabular and aggregation models. You can consider this something that is better to see live, and how he's going to be explaining it, than something that you might just read.
Howdy all. Yeah, thanks for that, Matthew. As stated, senior developer at Allotrope, I like the techie bits. So my plan is to sort of do a little bit of a run through on how you put together one of these models, what the sort of the basic process is for putting together the submission that needs to come to the modeling working group for a model. Can I take control of the presentation, because I'll need that to do the demonstration? Yes. So I was going to go through a very brief run through about tabular models, and particularly the difference versus aggregation models, and then jump into how you build a model with that Excel spreadsheet that Amnon alluded to earlier, particularly how you might build an aggregation model, which hasn't been necessarily seen yet, because that's a fairly new piece that we're adding. So as I said, for those that maybe weren't tuned in earlier, tabular models are just a set of key value pairs, kind of like a table. The keys are terms from the Allotrope ontologies, and they provide a bridge to semantic usage. The context is represented only by the file that they're defined in, and as a result, duplicate keys are not in a file are not allowed, because they can't be distinguished from another. So you can see the little picture on the side over here. You've got a measurement identifier, a sample identifier, and a pH value. If you had two measurements in the same file, you wouldn't necessarily be able to tell which pH was for one measurement versus which pH was the other measurement, because there's no link between those graphs. So that's the limitation of the basic tabular model approach that's been taken to date. To combat that, we developed the concept of the aggregation models, which is a simple extension of these tabular models to allow multiple keys in the same file. We allow currently two kinds of aggregation. So concepts can be aggregated as a collection. So the example would be a peak list has a number of peaks. You have a peak list containing 5 peaks versus facets. So whilst I'd say a peak list contains 5 peaks, I wouldn't say that a peak contains a retention time. It's more an attribute of that peak than being part of a collection. So we differentiate between those two representations to allow a little bit more expressivity in the aggregation models. As Amnon mentioned in his talk, we've standardized on using Excel to represent data in a way that's accessible for scientists to be directly involved in the creation of these models, but still allow for communication between those scientists, SMEs, and the semantic experts to enhance the terms in the AFO and make sure that the models make semantic sense. We have a tool chain that automates the generation of the SHAckle of the ADF files and part of the SHAckle constraints from the Excel spreadsheet. We had that more accurately for the tabular models. There's still some work to be done to try and automate that for the aggregation pattern. So there is still a manual step to generate those artifacts out of aggregate models, but we're working on that at the present time. And for context, that completed Excel spreadsheet is the only artifact you actually need to submit to the working group for reviewing the tabular model into our initial government stage. So if you can create that Excel spreadsheet and submit it to typically the modeling working group at this stage, we can start that review and consider what needs tweaking and changing to make it into a model. It's not that deep an energy barrier to get going with one of these kind of models. So the next slide is basically the demo of the Excel template. So right, now let's see if this is going to work. I'm going to run us through a very, very quick example of how you create one of these things. So hopefully you can all see Excel, everyone's favorite tool. I know you're wincing, John, if you're out there. And so this is a template for sort of the tabular models, and particularly the tabular models with aggregation that we've worked on to try and lock down exactly what it is that is and particularly isn't required to create one of these models, and to make it easy for the tool chain to be created, because we had something of an issue where everyone was adding a useful column here and a useful column there, and the tools didn't know how to cope with that. So we've standardized on this approach to represent our data. It has a bunch of columns, which you can see. They match pretty closely to what Amnon showed earlier, but I'll go through them in a second, don't worry. It also has a few other tabs down here. I'm going to ignore most of the ones. The only two that we're going to play with today are the metadata, which you can see on the screen, and then the hierarchy. So let's kick it off. Now, being as I'm a software engineer and not a scientist, I'm afraid I'm going to go to my usual staple of LCUV as sort of my example, and use that to illustrate as we go through. So each of these columns has a role in what we're doing. We'll start at the front, which is usually a good way of doing things, and go with the metadata ID. This is particularly important for aggregation. It's not actually used in any other way, but it's key for the aggregation. And all it is a unique value for the row. So the easiest thing to do right now is to just put in 1 and carry on iterating as you go through. We may try and automate something like that, something for that in the future, but for now, it's just a unique number to identify the rows. Then we get to parameter type, and this is more or less a convenience for SMEs and semantic engineers to understand what it is you're really trying to record: results data, metadata. These things are set. I'll briefly mention some of these restrictions. These drop downs are set via the data restrictions tab, so we can always extend this later. I believe there's sort of some other approaches that haven't been included in this, such as process metadata. But for now, let's just say we're going to add some metadata to this. So tabular models tend to record, sort of to date, they've tended to focus on the results of an instrument. So usually the first pass of a tabular model goes through the reports of a couple of different instruments in a space and pulls out all of the different parameters that go on that report to say, okay, this is what we're going to capture. So parameter name, the parameter name field here is basically meant to be more or less the manufacturer's parameter name. This is what it says on the report. Sorry, a little bit of water. So, for example, for LCUV, you would probably expect to see peaks. That seems like a reasonable parameter name to me. you'll probably see multiple of them, so which is why we're doing the aggregation, but we'll get to that in a sec. Now we start getting into the meaty bit. Parameter pref label and parameter allotrope URI. As Amnon mentioned, this is where you start mapping things to allotrope's terms. So sometimes we'll have a term for it already, particularly if it's crossing over with a domain that we've already covered. Sometimes we won't. So for now, LCUV does have this stuff, so I'm going to show you how you might search for this stuff. So I've opened up BioPortal, which is one of the websites that Amnon showed earlier, and you can basically use this to search for terms in the Allotrope ontology conveniently without installing any software or anything like that. So I figured it was a good thing to show. So we know we want allotrope terms, so I can type in AFO over here, and lo and behold, the Allotrope merge ontology suite is available for use. So if we click that and load it up, this brings up the whole thing. We can go to the classes tab, which is being a little bit slower now that I'm on a video chat. Fancy that. And you can then use the jump to field to search for things. So we said we called it peak because that's probably what you'd see on a report. So if we put the word peak in, what do we get? Eventually we'll get something. This was a lot faster when I did it yesterday. Here we go. And you can see a whole bunch of options. I'm going to start with peak because that's probably a good sensible start. The downside of demos, never do them live. Here we go. So by doing that search and clicking on the thing, we've got a nice little summary of the peak term in the allotrope ontologies. Peak describes a part of a data distribution, blah, 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 you know, all very detailed and correct. I'm going to say this is probably a good term for usage. This is the kind of thing that can be debated at the modeling working group. So yeah, if you're not sure, but it seems to be fairly close, you can always put it down and have that discussion after the submission. But as a first pass, I would say this is probably a good fit to the peak of an LCUV model. So we have two things that we need from here: the preferred name, which maps to the preferred label that we talked about before, and lo and behold, it's actually peak. So we've got that one very easily mapped from our manufacturer term. Peak means peak. The other part is the ID, and that's the IRI that Amnon's mentioned before, perl.allotrope.org/ontology/result #AFR00000413. Nice friendly mouthful there. So I'm just going to copy that rather than type it out and paste it in here. Parameter pref label is peak, as we discussed before, and lo and behold, that's those two fields filled out. Now jumping to the next two, sometimes, as I said, we'll have terms already in the ontology, and you'll be able to find them through the BioPortal, through the OLS, or through other tools like that. Sometimes we won't, or maybe you won't find them, and you know, we'll have named them a different way, or you know, they'll be slightly more slanted to a different domain, and so the term that you search for isn't necessarily going to match exactly. So in the case that you can't find a matching term and you think one needs to be defined, we've included these two columns here. So one for term definition and one for term scope note. And this lets SMEs and the semantic experts basically collaborate on defining what the new term is meant to mean. So if we didn't have peak, you could put in a definition here. Allotrope tends to favor, because of the basic formal ontology that we inherit from, we tend to favor using the style of Aristotelian definitions that they use, which is more or less A is a B that's C. As the parent, this is a child of some parent that is different from its siblings in this way. So that's the semantic definition, but of course you don't need to worry too much about that. If you throw down something and put it into the modeling working group, the semantic experts there can help finesse things. So the definition will eventually become probably something along those Aristotelian lines, assuming that we don't find an equivalent match. The scope note, on the other hand, because that's not necessarily as friendly to your average scientist, this arcane approach of describing things. It is important for the semantics, but it's not that friendly to a scientist. So we've included the scope note field as well, which allows you to just provide a little bit more context in a free text kind of way, give an example, sort of do a bit more explanation without having to be fitting this specific definition. So that's what those two fields represent. In this case, because we already have a term and we're probably fairly happy with it, we don't need to fill them in, but that gives context for why they're there. Now, in terms of required, funnily enough, you can have it as required or not required, and that just says whether it's mandatory or optional. Now, I'm pretty sure you can get results that don't have any peaks, so requiring it's probably a bad idea. So I'm going to say that it's not required and go from there. Now we get to the parameter data type. So the tabular models you saw before, you've got a key and you've got a value. And the key is some term in the Allotrope ontologies, and the value is usually some sort of literal value. It's a string or a double or a date or something like that. This is where you capture what that type is: string, date, double, all this kind of stuff. The slight oddity for those that have used the previous Excel spreadsheet but haven't seen the aggregation one is a peak doesn't really have a value. It has attributes, but it doesn't itself have a value, which is why, along with all of these things, double, float, long, short, all this kind of stuff, we've also added the aggregation parameter data type, and that just means it doesn't have a value. It's not expected to have anything. It's a container for other things in practice. And then these three fields are to provide real values. I'm going to skip those for now because we'll cover them in a minute. So we've defined our first field, a peak. Not very interesting, not really a lot to go on there. So let's go with the next one. So let's jump to row 2, add some more metadata. Peaks tend to have, I think, retention times are probably pretty useful. So we can say that the retention time of the peak is something that we'd probably want to capture. So now again, we can go to BioPortal and see if we can find something that matches that. Retention time. What do you know? Retention time. It's almost like I've done this before. So retention time, it's chromatically free facet, blah, 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 that it describes the elapsed time. Again, no scientist, but that sounds like a pretty good match to me. So I'm going to say that that's the ID we want. That's the term that we want. And we can go retention time, paste that in. Again, because we already have a term, we don't need to worry about the definition or the scope notes, so that's fine. And because the peak isn't required, I don't think it makes sense to require a retention time if you don't have a peak. So I'm going to go with probably no. Scientists might disagree with me there, so that's the kind of thing that could be debated in the modeling working group if something is required or not required. But use your first pass guess and go from there. So in this case, retention time is an actual literal value. It's not a container for something else. It has a value. So it's a number. I tend to store numbers as doubles. So let's go with that. So the example value in this, let's say 3.67 minutes. So this is where these three fields come into play. So you have an example value, which is just what the actual content of it is. You also have the units, and we have two fields for the units, one for the symbol, which is what you should see if you ever print the symbol out, and one for the URI for that unit. Because again, the unit is an important part of the semantic content. So you've got to say this unit. You know, min in theory could be minute, but it could also be other units with that sort of abbreviation. So we want to make it explicit exactly what we mean by minute. Now, unfortunately, something I discovered is that BioPortal doesn't capture the QUDT unit ontology, which is where we're drawing our IRIs for this from. So instead, I'm going to cheat slightly and use Ptashek. This is a free tool that's available to view ontologies. I'm not going to go into it in depth at this point. If you're interested, just Google Ptashek. The tool is there, and you can almost certainly find various tutorials on it, but it's a little out of the scope of this tutorial. So I'm going to go with minute, and yeah, as you can see, there's actually a bunch of different potential things that you could mean by minute. So let's go with minute time. That seems like a good fit. And what we have up here is the IRI for that minute time. So I'm going to copy that, paste it in here, and now we've got a retention time of 3.67 minutes with that minute URI and with the Allotrope URI right there. Okay, so we've got a peak, we've got a retention time. Let's add a little bit more to that maybe. Again, we can have metadata, and let's say, I don't know, peak description. So we want to say what this peak is, or give it some sort of context. Again, we can go back to BioPortal and see peak description. Oh, we got nothing. So we can either go and try and define a new term, or we can do some searching around. Rather than try and defining a new term, because like I said, I'm no scientist, not that kind of scientist anyways, I'm going to cheat and say, well, I do know that there is a description term, so a little bit of searching around is often useful, and I'm going to use this. But again, that would be an example where you might, after a little bit more searching around, go and use those definition and scope note columns to define what it is that you're talking about. Helps if I write the right thing. Description, not description. I'm not even sure what I typed there. So description and the IRI for that description term over there. Again, I don't think it's required. We don't need these because I've found something that matches. You only need to fill these in if you can't find anything that matches. And this time, I would say it's not a number, it's probably a string because you want to describe it. So I'm going to call it the imaginatively named peak1. And because this is a string and not a number of some description, you don't have to specify a unit. It doesn't really make sense to. So those two columns again get left blank. Seems easy enough, right? So by that, we've defined a peak, we've defined a retention time, we've defined a description for the peak description. Let's do that again, just to clarify how we do this stuff. If you want multiple peaks, and you probably do, then repeat the approach. Let's say the numbers are a little bit different. Let's say the description is a little bit different, but otherwise it's the same. You've got a peak, you've got a retention time, you've got a description, and there they are. What we don't currently have is a way of kind of grouping them together. So I'm going to add one more piece here, and that's going to be my peak list. So because I think, generally speaking, these things tend to get put together in some form of list. So if I search for peak list, happy days, there's a term for it. There is also, as it happens, a term list when you don't have something specific to peaks. So there's generally something for this kind of thing, but I will use the more specific one this time because I know it's there and I think it's a better description. So if we say a peak list, again, it's not required because you could in theory have no peaks. And this again is another one of these aggregation things. It doesn't really have a value. Its role is to hold these things. So to recap, we've got two peaks with retention times and descriptions, and we've got a peak list, which in theory is going to hold those. But at the moment, we don't have any relationship between those. This is purely the tabular model at the moment. You'd end up with some duplicate peaks and duplicate retention times. You wouldn't be able to represent, or you wouldn't be able to differentiate between them. So that's where the second tab comes in. This is where the hierarchy tab fits. So we'll quickly jump to this. It's not the most convenient thing in the world, unfortunately, because of the limitations of using Excel, but it is what it is, and it's workable if you understand how it works. For those of you who've done anything with databases, this tab pretty much fills the role of a bridging table. It just lets you say this relates to that, that relates to this, how do they relate, and all that kind of good stuff. So it's only got 4 columns, dead simple. Metadata ID, and funnily enough, that matches nicely with the metadata ID here. That might be deliberate. Parent metadata ID, and that's going to be your the parent to your child. So these two things will have a relationship. That's how we're representing it. Then we're going to capture the relationship type. As I said earlier, we've got two different kinds of relationship allowed. We've got facet of and member of, and I'll go through that in a second. And then for the aggregation index, in the case of, say, a peak list, you tend to have them in an ordered list. They usually have some sort of index attached to them. So this is how you'd apply that in those cases. It doesn't make so much sense for facets, but when you've got members, it absolutely is a useful thing, though it's not required. In theory, you could have a list that didn't have indexes, and that should be fine too. So going back to here, so the retention time and the peak description are facets of this peak. So 2 and 3 are facets of 1, and we would represent it like this. So metadata 2 has a parent of 1. So because this is a facet of that one, and we would go facet of. So now this peak has a facet of retention time. We do the same thing for row 3. So row 3 has parent ID of 1, has a facet of. So this peak has a facet of peak description. So this peak has a retention time of 3.67 minutes and has a description of peak 1. Simple enough, I hope. We can do the same for this one. So peak 4 has peak 5, has a row 5 and row 6 as facets. So 5 is a facet of 4. 6 is also a facet of 4. So this peak has a retention time of 4.27 and a description of peak 2, because 5 and 6 have a parent of 4 and they're facets. Now the last bit is the member of. So the peak list has 2 peaks, peak 1 and peak 2. Seems to make sense. So let's do that. So peak 1 is row 1 and the parent is row 7. Now this time, because it's not really an attribute of the peak list, but a member of the peak list, we go member of, and it seems sensible to make it an index given it is peak 1. So let's give it an index of peak 1. Likewise, row 4, because row 4 is the peak, has a parent of 7. Again, it's a member of, and this time it's peak 2. Let's give it index peak 2. That's that. So between these two tabs on the spreadsheet, we've now represented a peak 1 with retention time of 3.67, a label of peak 1, peak 2 with a retention time of 4.27 and a label of peak 2, and the peak list, which says that peak 1 and peak 2 are members of it, and peak 1 has an index of 1 and peak 2 has an index of 2. That's basically it. That's how you represent the both the tabular model, the key metadata about the things, but also the aggregation, the relationship between things in the Excel spreadsheet. So hopefully that's reasonably simple and easy enough. Again, you can find the terms using BioPortal or Ptashek, and yeah, if you can fill in that kind of thing as a first pass for your technique and submit it to the modeling working group, that helps us to then refine that to make sure the terms are correct, to make sure the relationships are there and that the key bits are present to put that on the path to governance. So you've seen that aggregation template. Here's one I prepared earlier. And all I've done is color code these metadata IDs to make it easy to see that the relationships are here. So 2, 3, 1. I've done this in slightly different order because I've put the indexes up here, but you can just see that the relationships are this is a parent of that, this also has a parent of that, these have parents of that, and so on and so forth. These would be in the submitted resources for this talk. That's the word I'm looking for. Now that Excel spreadsheet should then translate into more or less this graph. So this is just a visual representation of the data that we just captured. So we'd have a peak here with a description of peak 1 and a retention time of 3.67 minutes, and a peak here with a description of peak 2 and a retention time of 4.27 minutes. Peak 1 is in the peak list at index 1, and peak 2 is in the peak list at index 2. This is just the straight visualization of exactly what we've gone through, and the intent is that the tooling, when we are able to extend it with the aggregation pattern, should automatically generate the ADF and the RDF turtle representation for this, and ideally also partially or even completely, if we're really lucky, generate the SHAckle that is used to constrain this and make it into an ADM that can be published. So the tooling is currently for use by the modeling working group to develop models, which is sort of how that tool is going to be positioned at the moment. But you can sort of see how that's meant to be represented, and it's not too painful. I think it's, as I said, for the tabular models, the Excel spreadsheet's been used fairly extensively so far, with quite high success with between SMEs and semantic experts to do this work. So this is just a straight extension of that, and hopefully it will work nicely. And with that, I think we are at the end of our little talk. So thank you from me, from Matthew and Amnon, the product team as a whole. And I think we can probably go to questions at this point.
Great, thanks Ben, Matthew and Amnon.